Let us now take a look at some facts about light and see what kind of information that provides us regarding atoms and molecules. So if you have light and it's produced by a sample of matter, so you got a sample of matter, it produces light. That light that's produced is called an emission. Okay? Now, if you were to spread that or separate that light into its component wavelengths or different wavelengths, okay? That, like just like a rainbow, you've learned from your early science courses, you can run light, for example, through a prism. It separates into different colors. Okay, so uh, when it separates the light coming off a sample of matter into different wavelengths, what you observe here is called the emission spectrum. Okay, so emission simply refers to light being produced by a sample. So what does that tell us about atoms and molecules? Well, let's take a look at a typical observation you might make. If your light source, the sample of matter that produces the light, has a high concentration of atoms, that means you got a lot of atoms crowded in a very small space. Okay, so for example, in a solid, the atoms are as close as possible to each other. So an example of that would be like the filament of a light bulb. Okay, so you run electricity through it, it produces light. Okay, and if you were to split that light into its component colors, what you typically see if there's a high concentration of atoms from the light source is what's known as a continuous spectrum. Continuous in the sense that you have a continuous band of colors just like a rainbow, and you get to appreciate a little better exactly why we call it continuous if you look at what happens if your light source has a low concentration of atoms. So if the concentration of atoms in your light source is low, for example, if you have a gas sample right here, so you have a hot gas, it produces light, and you were to examine the light that's produced by the hot gas, so separate it into its component wavelengths, you can see you get what's called a line spectrum. So this is a line spectrum. So this particular emission spectrum from a source that has a low concentration of atoms is a line spectrum. You can see it's mostly dark areas with very bright lines, a few bright lines in between. Okay? Now, this is called the emission spectrum, okay, or the line spectrum of the atoms that are producing the light in your hot sample of gas. Now, each particular atom or molecule has a unique spectrum. So, for example, if your sample only contains hydrogen atoms, in other words, the only atoms producing light from your sample are hydrogen atoms, and the concentration is low, this is typically what you'll find. This is a characteristic of hydrogen atoms. So, in a way, the light being produced by atoms is an identifying characteristic of the atoms. It's their ID number, you might say. It's their fingerprint. Okay? Each atom has a different spectrum, characteristic spectrum. Now, if you were, imagine you had a continuous light source, a continuous spectrum like a lamp here, okay, your light bulb. You pass it through a cold sample where the concentration of atoms is low. So this cold gas right here has a low concentration of atoms. You pass the light through it, and then you examine the light that comes out, okay? And you split it into its component wavelengths. You'll find that instead now, remember, without this cold gas over here, okay, if you did not have this cold gas right here, if this wasn't there, you get a continuous band of colors, but now you see these dark lines because of the presence of that sample of gas there in between the light source and the prism. Here you see these dark lines, okay? So those dark lines, okay, are also unique for each atom. So the pattern that you see is unique for each atom. Now this one is referred to, this particular observation right here is called an absorption spectrum because these dark lines right here are due to light from the source that have been absorbed by the atoms in your sample, which in this case is the cold gas. Okay, and again, each atom or molecule has a unique absorption spectrum. So this is what you would see for hydrogen. This is the absorption spectrum that you would see for sodium. The question is, how do we explain this? So what does this tell us about atoms and molecules? This tells us something about the energies of atoms and molecules, and we'll look into that in the next video.